Today's lesson is about how to do the chi-square test in your IA. I got this data from this website. I just used the first 50 data to show you how to do the chi-square test. First of all, we put into graphing calculator to get two variable statistics. Get this value. I want to get the average, so I got to use this average to figure out which data is above, which data is below the average. First of all, I need to insert a column next to the height and also the weight. So I highlight this column. So right click, insert, column to the left or to the right. Yeah, I need a column to the right. Do the same thing for the weight. Then right click, insert, to the right. And make it a little bit narrower for this column. Then I will label each data. Remember, for the average height, that's 68.05. For the first data, 65, I will use B stand for the below. Below the average, I use A stand for above the average. Therefore, for 65.7, I will label as a B. 71, that's A. 69 is A. 68.2, that's A. 67, that's B. So I will do the same thing for the weight. Weight average is 128.8. Therefore, 112, that's B. 136 is A. 153 is A. This is A, and this is A. You keep doing the same thing and label all the data. After I finish labeling each data, then I will check to see how many is AA, how many is BB, how many is AB, like this, or BA. I use the different color to label. All BB, I use this purple. All AA, I use green. BA, I use blue. And AB, I use orange color. Then I just count. I got the AA is 16, BB is 17, AB is 7, BA is 10. I will use this template to work out the chi-squared test. They show you the steps. Step 1, state HO and H1. HO, which is the null hypothesis, equals. In my situation, it will be weight is independent of height. H1, the alternate hypothesis, equals weight is dependent on height. If chi-square is greater than the critical value k, we will discard the null hypothesis and accept the alternate hypothesis, vice versa. For step 2, construct the expected frequency table. Top 1, you can see above the average height. This column, I will say below the average height. Here, I will say above the average weight. The next one I will say is below average weight. Here I need a total. This part is a total. So I need to delete these two columns. Then make it wider. You can make the word smaller. So I go to the home and I can change into 12. So that it's nicer. AA, that means here, put the 16. BA, that's 10. AB, that's 7. Here, that's 17. So you add this together is 26, 24, 23, 27. So we have 50 data. We call this table is observed frequency table. Then you need to make a expected frequency table. So same thing, I need to delete this. I will copy here. Okay, so how you work this out? This is the one I can get from insert equation. Then go to here, you click here, fraction. Then they show you this fraction, you go to use. Basically, it's 23 times 26 divided by 50. That's the expected data for this column. So I use 23 times, I will use this symbol here, times 26 over 50. That's over this number. For this one, you go to use 27 times 26 over 50. So I do 27 times 26 over 50. This one, you got to use 23 because the corresponding will be 7. So we do the 23 times 24 over 50. For this one, corresponding is 17. So total is 27 times 24 over 50. Then you can work this out, get the answer. After you calculate each math, then try the total. You adding these two supposed to be 26. If you didn't get the 26, there's something wrong. This adding these two will be 24. Same thing here. Adding these two, it will be 23. Here, 27. And this one will be 50. After you finish the expected frequency table, you really need to check the data in the table. Make sure the data in the expected frequency table must be greater than 5. Otherwise, the chi-square test is not valid. So if you have some data has the value less than 5, you need to get more data. Or recombining the data will be the solution to solve this. That's the reason when you get data, at least 30 data for each category. Otherwise, when you do the chi-square test, you will get some value less than 5. This is a very, very important, critical to chi-square test. Then we go to the third step, work out the degree of freedom. That is 2 rows. Look at the observed frequency table. Your data, you have 2 rows of data, 2 columns of data. Total won't be counted this time. Since we have 2 rows and 2 columns, so our degree of freedom equals 1. When degree of freedom equals 1, you cannot use this formula. When degree of freedom greater than 1, using this formula, you have to use this formula. We call this is Year's continuity correction. So we put in this number. FO means observed. FE means expected value. Then you do the FO minus FE. Remember using the corresponding values. So we have FO means observed. We have 16. The corresponding will be 11.96. So I put here 16, 11.96. For this one, it's 10. Corresponding will be 14.04. Keep doing the same thing. Then you will fill out this table. Let me delete these two rows. And here, you can change this into math symbol. So as long as you click, go to insert, this one, then you can change every single number into math symbol. Don't highlight the column. You just need to highlight this number. If you highlight the column, I don't think it works like this. Yeah, it won't work. So you have to do one by one. In this way, we can figure out this chi-square value will be 4.0424. We already got the value for chi-square is 4.0424. You need to compare this value to the critical value. Since degree of freedom equals 1, we use 10%. That is 2.706. This chi-square value is 4.04. So you got to use chi-square test greater than k. So we will delete this. You will see as chi-square greater than k, we can conclude that HO is rejected at a 10% significance level. In other words, weight is dependent on height. Another important note. When degree of freedom equals 1, graphing calculator cannot perform a chi-square test. In other words, you cannot use a graphing calculator to check whether your work is correct or not. Only when degree of freedom greater than 1, you can use graphing calculator to check your answer. I will show you how to use graphing calculator to perform chi-square test when degree of freedom greater than 1. Now I will show you when degree of freedom greater than 1. Then you can use graphing calculator to check your answer. Suppose you are working on an IA about hair color and eye color. You got this data. Suppose you already figure chi-square value out by showing the work in your IA. But in IB, you are encouraged to check your answer. So since the degree of freedom greater than 1, you can use graphing calculator to check your answer. Now I will show you how to use graphing calculator to perform this chi-squared test. First of all, you need to go to second matrix and go to edit. You have 1, 2, 3 rows. So 3, enter, 4 columns. Then you will put the number in 14, 10, 21, 5, 11, and 4. After this, you need to quit. Then go to Stat, go to tests using this button to get a chi-square test, that's C. So go to this C, enter, enter, enter. See, this is the chi-square test value. And they also give you degree of freedom equals 6. You can go back to your matrix and go to B. Then they will show you the value for expected frequency table. If you do math, enter, enter, then they will show you fraction. It's more accurate. So we know that when degree of freedom equals 1, you cannot use graphing calculator to perform the chi-square test. But when your degree of freedom greater than 1, please use a graphing calculator to check your answer. Then show this on your paper, because IB Math IA, you are encouraged to check the answer.